In this tutorial, I'm going to show you the basics of using the camouflage evolution toolbox, CamoEvo. To use CamoEvo, you will first need a version of ImageJ that has either got CamoEvo prepackaged or has the CamoEvo plugins installed. In this instance, I'm using CamoEvo version 1.21 for Windows. So load up CamoEvo. You should get the following UI. If for whatever reason you close this UI, do not panic. Just click Exit Game, Plugins, One CamoEvo game, and the UI shall reload. And as we're going to be creating a new population in order to demonstrate the evolution, we're going to go to New Game, and it will direct you to upload a series of photos. These will function as the background in which your targets evolve against. As we're not interested in doing this for any kind of experiment, we can use any sort of backgrounds we want. So I've taken the liberty of finding a leaf litter background on the internet, and what I've done is I've just made 3 additional copies of it horizontally and vertically flipped to give 4 different variations, and these will function as our backgrounds for this demo. As you can see, they are all currently the same size, and ideally you want to pre-crop all of your images, or CamoEvo can crop it for you. It's much more reliable to do it beforehand yourself. So now that we have the photos, we can simply select the leaf litter backgrounds folder that we've already made. It's really important that within this folder you just have the images that you wish to use and that there are no additional files. So we're going to select that. We do have the option of creating our own custom targets, and I'm going to show you how to do that later. But for now, we're going to use one of the default targets, and we're going to use the tier shape. There are additional advanced settings, but for now we're also going to use the default, which is 24 individuals evolved over 5 generations, with selection being for camouflage. And we're going to name this population tier, and it should begin to generate our new population. If you go into the plugins folder for ImageJ, One CamoEvo populations, you should find your new population here, including the 4 backgrounds. These have all been automatically cropped to the default settings for CamoEvo, which is an image of 1478 by 1130 in size. You can adjust these manually, and I will also be producing a tutorial on how to start up the game without using the UI. It's now generated our targets, so here are our 24 tier-shaped targets using the default CamoEvo color space, and we're going to quickly evolve these over the course of 5 generations. So for the game, it will direct users to move their mouse to the center of the screen. Once they do so, it will then present the new image, and you repeat this for all of the slides. CamoEvo records both the time in which it takes for you to move from the center of the screen and the time it takes for you to click on the target, using a hybrid of this as the recording for capture time. Now that we've found all the targets, it's going to start generating generation 1. As you can see, we've got all of our targets from before. We've got the genes here. These are the genes that encode all of the targets. You've got the ranks. So this is all the fitness values. As you can see, there's the measurement of survival time, which is the hybrid measure. Response time, which is the time for you to move from the center of the screen. And there's capture time. And it's also recorded all of the data regarding the actual coordinates of the target and where the person clicked. We can also see a recording of the average fitness time, so the average fitness was just under 1 second, which is not bad for leaf litter for generation 0. If we go into the settings of the population, we can see that the survival method has been set for the measure method. If you change this to capture, it will just use the click on time, and if you change this to response, it will just use the response time. We can see the color space, so we're starting with a narrower color space, but allowing for exploration into the whole color space. Transition setting is set to center, and no demo images are used. This is a latent feature and will be expanded upon in the future. For the settings for the actual game, we've got the range of angles the targets can use, the number of targets per slide, timeout time, the spawn method, so this determines where the targets go on the screen, the capture method, which is set to response time. Note this is independent of the method that's used by the actual fitness ranking. Instead, what this is used is to determine what counts as a click or not. So you've got the click method, which is you just click on it, and you've got the left and right method, which is where you left or right click if it's on the left or right sections of the screen. And you've also got the rank method, which will change the dialogue in terms of what the game asks you to do. It doesn't actually have any bearing on the fitness. For the transition method, center the screen, but you can replace it with a click or a automated timer. There's no training targets, the training number is set to 0. There's no repeats. This is a somewhat latent feature. It does work, however it is not currently built into the camouflage evolution cycle. Click leeway, so this is the area around the target which you can get away with clicking. The crop dimensions, crop mode, so this is cropping to the center rather than a random position. Fail trigger, so there's currently no fail trigger, but you can set it so that if someone misses a target, it counts as a timeout. This can be useful for instances where you have multiple targets on the screen. And there are currently no target or image modifiers, and this is something I'll also do a tutorial for. So, as you can see, our targets for generation 1 have been made, and so we can get back to the game. And from now, we'll just speed through until we get to generation 5. And there we are. We finally got to generation 5. It's prompted with the game complete screen. Well done. Finish the game. You can either click keep playing. This will extend the number of generations by +5. So it'll be 10 instead of 5 generations. Or we can hit camo analyses. This is what we're going to collect. Click, I should say. And it will start to analyze. This takes roughly 30 seconds to a minute per generation. So it should take about 5 minutes or under to run. We have all of our generations complete. I made a terrible mistake playing leaf litter as it took ages, simply because the background itself was quite difficult to begin with. Before we generate the plots, we can just take a glance at the fitness average.txt file. As you can see, the fitness rapidly improved. This is because the population stumbled quite early on a good background match for the leaf litter and committed to it. And I'll be able to showcase these properly shortly. One of the advantages of starting with a narrower color space and allowing for exploration early is because color match and luminance match are particularly important for camouflage, and there's no point wasting time starting with lots of blue individuals, but by allowing exploration to the full space, these individuals are allowed to emerge later on, in order to demonstrate thoroughly that being blue is not a very good idea for camouflage. Already finished. We can either download the data, which will make a copy of the .txt file, or we can hit preview results. We're going to go with preview results. As you can see, fitness improved, taking on average less than a second, and then almost just over 3 seconds. And the deviation in fitness also increased, or the standard error, I should say. These are the fittest targets. As you can see, they're a decent color match, and they're starting to develop these destructive stripe patterns. The luminance match is pretty flat. This isn't too surprising for leaf-litter backgrounds. The contrast match is also pretty flat. It is the color match that is particularly the color difference that's particularly decreasing. And it's normally once you get to values that are less than or around 10 that the camouflage gets particularly good. And as you can see, the deviation is also rapidly curtailing off. And the edge disruption is also pretty flat. So it's only been 5 generations, so you shouldn't expect to see massive changes. But we can see that color seems to be an important aspect of selection in this instance, with luminance difference actually increasing slightly for the population overall. So these are our targets. We can also go on genes. The gene variation plot is designed specifically for practicals, particularly for A-level students, and to some extent undergraduate students. So we can select one of the genes. So if you select parent, nothing will happen because parent's not a gene. But if we select, for example, the color top LMV, so this is the luminance value for the top color, we can see that there is an element of directional and stabilizing selection. If we decide instead to take a look at the red-green value for the maculations, we can also see an element of stabilizing and directional selection, or gene fixation. If we download the data, we can select a folder in which to move our data to. However, we don't really want to do that. So now that we've finished our game, what we can do is we can create a nice plot. So we can go plugins, CamoEvo, get phenotype plot. We select our population, tier leaf, and we can customize some of the settings for the plot. So we start at generation 0, we ended at generation 5. We can have a generation interval of 1. We can show all of the individuals we wish to, but let's just show the top 8, as these are the ones that get to breed using the default settings, as it's the top 33.3% or the top third. Block size, columns per block, determines how many columns there are per generation. We are going to go with 2, so it should be 2 columns of 4 individuals. Then we can set the spacing, so we're just going to use the default spacing. We can select a rotation, so we can rotate the shape. I think it's nice to show these with a right rotation, so the tier will be facing horizontally. And the ordering method, we're going to use fitness, so they're going to be ordered by rank. So the 8 individuals it's going to show will be the top 8 individuals in the population. We're going to show the individual label, and we're going to show the generation labels. And here we are. So as you can see, the individuals that survive, particularly in generation 0, are quite leafing, quite brown, barring some exceptions. And the general pattern that's evolving is ones which have these long sort of disruptive streak and also have this very leafy color and pattern. Again, this is only 5 generations. If you're unhappy with the spacings at the bottom here, or between the rows, you can adjust those with the settings. We can also make a GIF. We're going to adjust the settings though, so rather than having the rotation, we're going to remove the rotation, and we are going to have 6 columns, and we're going to show all 24 individuals. And it's going to now start to make a GIF. There we go. And if you click the play button down here at the bottom, it will play. With image J, you can adjust these GIF sessions. And that concludes our demonstration.